Welcome to AML Conversations, the Solution Series. This podcast series focuses on practical information about solutions to challenges you face in your financial crime compliance program. These solutions include managed services, technology, advisory, and third-party risk management. You can access this series and other AML Conversations and This Week in AML podcasts at our website, amlrightsource.com, SoundCloud, or wherever you get your podcasts.
Hello and welcome back to the Solution Series. I am joined again by Leandro Loss, Principal Data Scientist at AML RightSource. Hi Leandro, it's great to have you back.
Hi Rachel, thanks for having me back.
So as some of you might know, we have been exploring artificial intelligence as a topic. And in our previous two episodes, we discussed the different branches of artificial intelligence and if we can trust it. In this episode, we're going to be talking about large language models such as ChatGPT and their application in compliance. I think that leads me nicely to my first question. So, Leandro, could you explain what a generative pre-trained transformer, or GPT as it's commonly referred to, is?
Right. So, let me start by saying that GPT is truly a game changer. It's a game changer for the public, I would say, because this race, the AI race, has started many years ago. And in particular, the generative models or neural networks have, been developed for at least 2 years, including the current one is the fourth generation. The GPT-4 is the fourth generation by OpenAI. It's an organization that was backed by Microsoft, and in part is their secret for the success. Why is that? Because GPT was one of the first model, and let me backtrack a little bit and explain what the GPT is. So it's just a big neural network, bigger than anything we were able to work with, train, and deploy in the past. So, and going back to Microsoft, the secret here is that they got basically a chunk of money in the order of $1 billion. And we're able to basically use the hardware to unlimited hardware that would cost a different company several millions of dollars to do so. So very few companies would be able to do that. GPT then uses this a type of neural network called a transformer. It's also a revolutionary piece. So GPT is basically the combination of very successful techniques in machine learning, combined with access to unlimited resources, computational resources, and they're basically able to create a language model. We can explore a little bit what the language model is, but they're able basically to create a bot, in layman's terms, that is really able to have a conversation, a high-level conversation with a human being. And that's why the game changer comes from being able to engage the general public in such a natural way and raise so much attention, right? From the technology perspective, as I said, it's a transformer network, a transformer neural network. So it has been there for at least 8 years now. It's generative in a sense that it produces results, which is slightly different from what neural networks are traditionally used by when they have to categorize something, which means, select from a few labels as output, as answer. And the pre-trained part of the name comes from the fact that they train these things on trillions of examples on text, producing this, what it's called the foundation model. And I can, again, explore a little bit about that if we decide to talk about language models. They're able to pre-train this guy and create this huge neural network that is able to address problems from different domains, which is also a new thing. Traditionally, machine learning would address a particular problem, very narrow chunk of what we call intelligence. So the GPT, going back, wrapping everything out, the generative part is it creates new information, it creates new text, pre-trained because they already trained and made the whole model available for further training, for fine-tuning for particular problems like Chat GPT. It's the GPT model, the GPT foundation model, tweaked for chatting. And that's basically what caught people's attention. And the transformer is that type of neural network able to capture certain things about the text, that about natural language that is fundamental for how human beings communicate.
Leandro, you mentioned there a couple of times large language models. What are large language models? Could we unpack that a little?
Sure. Let me go back to our first conversation when we talked about AI. We started with data science, AI, and then inside AI, we kind of had two branches there. We followed the machine learning branch. We followed then the natural language branch. So a large language model, the name says it all basically, but it's a technique, one technique in natural language processing that, as I said before, it caught everyone's attention by the power of communicating, of engaging with human beings. Is it perfect? It's not perfect. It's still under development, but it's way better than what we're using before for this general approach to talking to anyone, right? I'm not saying about particular specific problems, right? Narrow slices of intelligence. So what makes large language models so powerful? First of all, they are large, but that's not really what makes them so powerful. The ability to be large is combined to the amount of data that you can train on. And that's the biggest to me. They have transformers, they have all these abilities, all these intricacies of the technology, the way they create the network, the architecture. But the most important thing that I think it's a very clever trick is that, again, traditionally, you have to provide the network with an input and an output. And that, depending on what you're doing, it costs a lot of money, a lot of time, because you have to basically have an expert there to say, every time I see this input and this is the output I want. And then you go to the next example. If I see this input, this is the output I want. Imagine how much time it would take to train a network that is that large on billions of examples. You'll probably have a team working for, years and years, maybe decades, on creating such training data. However, what's very clever about large language models is that they basically found a way of having training data for free because they can read. The idea is that you get all the text from the internet and you input a whole sentence, a whole paragraph into the network, and you remove one word at a time, maybe more at a time, depending on the company. They have different approaches. So the goal of the network is to learn the missing word. But the researchers know what the missing word is because it's available on the internet. So that's how they are able to have so much training data. But what happens now with that? So now they trained all this in trillions of data from the internet. Rachel, you can already imagine what the issues could be, right? I could go right now, open a website, input a lot of, create a bunch of fake text, and at some point, OpenAI or other organizations, Facebook, they would capture that text and input into their network. And basically, you would learn how to predict the next word, but it is not necessarily connect to facts, to what's true, what's reality, right? So the foundation models, then, they learn basically how to fill in the next word. Okay? Now, what's successful about this is that you now fine-tune, you provide much fewer, fewer examples for a very particular problem. That could be chatting, it could be question and answering, it could be some type of topic categorization of news or anything. So with fewer examples, you can say, network, I know you can do all these things. I know you were trained on trillions of examples, but I really want you to focus on this particular problem here. And that's why ChatGPT is popular among the general public, because it's able to have a conversation. Yes, it does give like some bogus answers, but the English, the language is really well put together, right? That nobody can deny.
I completely agree with you. Nobody can deny it. And I think the possibilities just seem to be endless. Along that train of thought, do you think these models are going to impact the world of anti-money laundering and financial crime?
So the answer is absolutely yes. Anyone should be able to use it in anti-money laundering. Um, Let me talk about two different things, two different aspects that have they're going to change. Search. The traditional search right now, you go on Google or Bing or a different search engine, you type whatever you want, and then you get 10 results per page. And then you go and investigate the first one, you open the second one, and maybe you like the third one. The third one had the answer, but you made that decision. Maybe you're doing some kind of survey, so you read 3 to 5 pages and you put the summary together. Maybe one of the pages is in Mandarin, and then you have to translate that, and you use a different tool. So what large language models bring to the table is that you can ask a question and give, if you tested GPT, for example, you're going to see that you can enter examples, counted examples, instructions, details about how you want the output or what type of output you're looking for. And it goes, by the way, originally it goes to its training data, to what it's seen before, which is truncated at some point in time, I believe in 2021. But now, just very recently, they started adding this concept of agents where the network can actually say, I don't know that because it's a recent answer, so I'm going to go on the internet and do that search. So things are evolving very fast, and the capabilities we're talking about today may be overshadowed by something even bigger in a few months or few years. But that's one aspect that I believe it's going to change the paradigm of search itself, where the network is doing that search for you, compiling the results, putting it in whatever format you want, in whatever language you want, and giving you the results. So you don't have to go through several URLs and stuff. That's one aspect. And why am I mentioning this? Because it's big in investigation, right? Investigators, they have to go either to Google or to their private sources, data sources, and they basically have to scrape through tons of data, tons of results. And you can imagine that, if you do a Google search, you see that lots of results are not useful at all. And sometimes they're related to something else. So that's one aspect. The second aspect, and I can mention several, but I'm going to mention the second one, data analysis. These large language models are able to answer questions related to insights, highlights, anomalies, interesting facts, calculate all sorts of statistical metrics, plot charts. So basically the data analysis itself. And by the way, you can do all this with human language, with natural language, not having a developer, a data scientist typing programming language into it. This is a big deal because anyone, Rachel, can have their data in hands and do not depend on anyone to code a user interface with a dashboard with a graph here or a table here. They can ask, they can probe the data in their own language. Knowing the domain language, they can be much more deep on what they're asking. The nuances of domain knowledge that a data scientist or a software engineer may not know and will do great statistics, but don't know what it actually means. So I mentioned this too briefly to say that that's all AML, right? You're investigating transactions, you're looking at KYC files, you're matching things, you're going to the internet, finding articles, finding sanctions, finding politically exposed persons. You bring all this together to make a conclusion, to adjudicate if that's okay or if that's suspicious. By just those two things that I said, you can already see that things are going to change if we adopt this technology. It will change, right? Positives and negatives, pros and cons. I believe it's a pro because there's a lot of pros to it, because it is boosting the work by the investigator, right? A lot of the laborious, tedious work that the investigator have to go through, it's basically automated, but it doesn't remove the human being from the picture. And just to mention a con here is that it's a change. People are going to have to change. They'll have to adopt a new technology. They would have to adopt a new tool. And for some people, it's stressful. For some people, there is insecurities around that. But remember, I think the most important thing here that may have been, washed off a little bit is that we're talking about communicating with such powerful technology using human language. So you don't have to learn a set of tools, a new set of tools. You just need to be able to explain what you want, explain how you want things. So, it's going to vary from person to person.
One of the most debated topics is if AI will replace humans. What are your thoughts, Leandro? Particularly with reference to large language models, will they replace human investigators?
That would be a great question for a panel. This is going to be the very biased opinion by basically an engineer for life that, likes technology a lot and is passionate and enthusiastic about technology. So that's my disclaimer there. Let me tell you then my perspective. This is no comparison to a human brain. It's a mimic to a human brain, but it's not a human brain. So I know we call it intelligence, but it's just mathematics. These are algorithms. They are not malleable. They're not creative. They're not. They don't bring in their cultural, social experience, maybe traumas. So there's all these aspects from the brain who can that can grow parts, like develop new paths, new neural networks. If something happens to part of the brain, that specialized parts of the brain to do different things, that combines memory and rationality with emotions in one thing. Neural networks are not close to that. These are mathematical functions that put together and using clever tactics to learn the parameters, the values, right? The variables of those equations. You get to results that are similar to for particular tasks, similar to the what a human being can do. For me, that's not a replacement for intelligence. Why am I saying this? Going back to the question, is it going to replace a human being? I would say it depends. If your job as an investigator is to validate if this ISO code matches that address, and that's all you do all day, is to find the ISO code for a particular address, I would say, well, that's very that can be replaced by artificial intelligence. If your job is just to find the line of business for particular companies, yeah, maybe it's not as direct as an address, but you go online, you find the web page. Well, that's also a set of steps, fixed steps that can be simulated really well by artificial intelligence. Now, if your job involves the human part of it, right? What is the human part of it? Is this ability to work in the gray zone? Yes, it's very easy to catch when the criminality is obvious. The red flags are all over the place. You have negative news about it and so on. And it's very obvious when there isn't much going on, right? There's like the obvious answers. those can be simulated by artificial intelligence. But there is a whole gray zone that I find hard to believe that a neural network today, this is today, it's not 5 years from now, this is not 10 years from now, don't use this out of context today. What we're seeing out there does not work in this gray zone. It does work, but probabilistically, you will guess the answer. You will not use information that it doesn't have, like human beings can do. Human beings have the ability of combining information that sometimes we don't even know how we know that, and use that from what they learned many years ago to say, oh, I've seen that before, and I think that's what's going on here, and that's how I'm going to take my next step in terms of investigation. So to conclude, I do not see language models or GPT replacing human beings. I actually see human beings maximizing their potential, the investigative potential, because they're going to actually be able to focus on the good stuff or the bad stuff, depending on the perspective, on the actual criminality, rather than on gathering data from the internet or matching things from different databases.
Leandro, I have one final question for you. Why are regulators so apprehensive towards AI applications like large language models and their inclusion within compliance programs?
I think the regulator's job is to be concerned, right? They have to be up to date. They have to be in close touch with the industry. Unfortunately, that's not really what happens most of the time. And I can tell you from experience that being in this business for 8 years now, coming from a small company that started with 4 people and grew to 14 and then 2000 with AML right source. I was there visiting with the founders. I was visiting bankers, compliance teams, sitting next to investigators, hearing from their experience with regulators. And if I go back 2016 to 18, nobody wanted AI. They were like, regulators will never accept a black box here making decisions. That's not how you work. You need to sign off, what you did, that kind of stuff. 2018, things changed a little bit. People start getting curious about it. So from disregarding it completely, the feeling went into curiosity because the results were there. They could see how much gain the human investigator could have, both in quality of their work, but also the speed in which they could adjudicate cases. From curiosity, we stepped into proof of concept. Let's say, hey, you know what? I can't use it right now in production, but let me use you in this, this data set that I separated for you, and let us know. And we're going to compare what we did. And from there, by showing what it could do, all of a sudden, maybe in 2020, 19, we see regulators incentivizing that, saying, hey, industry, you should look into AI solutions. So I can't even say it was a symbiotic, relationship between industry and regulators. I think with language models right now, there is no educated opinion from the part of the regulators right now. I think everyone is waiting for some spark of a solution that makes the news, and then, okay, now we have to do something. Because nobody's doing language models or GPT in AML right now in production. Nobody's advertising it. I could kind of crack a little bit the surface of what we do internally. So we are going to apply, and very soon we're going to have language model-based solutions, answers to not to everything. You're not going to pump transaction and say, find me the bad guys. But there are lots of solutions, red flags, that already use machine learning. They already use AI. They already have the blessing from regulators. So LLMs are artificial intelligence. They are machine learning. So I told you a long story of how regulators felt and acted on AI. I think it's going to be much easier now. There is already a learning curve in progress. And language models are just a new technique, the new kid on the block. And hopefully that learning curve is going to be much faster. But I wouldn't expect them to take the initiative. I think one of us are going to have to go out there and say, hey, we're using it. And then say, wait. So that interaction is going to happen by someone taking the first step and waiting for the feedback.
Thank you so much for answering all my questions, Leandro. This has been really insightful.
Thank you, Rachel. I'm looking forward to the next conversation.
And thank you, as always, to our listeners. Join us next time for our final episode on AI, where we will be discussing how it can be leveraged in compliance.
Thanks for listening to this episode of AML Conversations, the Solution Series. More episodes will be posted in the coming months. If you find this installment interesting, there is more great content at amlrightsource.com. If we can help you with your financial crime compliance needs, schedule a meeting on our website. Together, we can reimagine compliance.